Hello, buddy. Welcome. Today we are going to continue with this is part 3 of the series of lectures I've been doing on how to learn mathematics. And before we begin, I'd like to remind you that there is no idea that you cannot learn. And it doesn't matter who you are or where you come from. If you follow the laws of learning, you will learn. That's all that there is to it. So let's start the dance here. Well, we've been talking about how to acquire mathematical knowledge, and today I want to talk about one particular technique that is really useful, one of the laws of learning as far as I'm concerned. It's the idea of the hook. Alright, the hook. Well, let's consider a special example, in fact. Let's say this is a knot right here, and to this knot, let's connect a bunch of objects. Wait. Gotta erase that. Sometimes I get too excited. Alright. So we have a knot right here, and we connect it to some objects. This object, and that object, and a third object. And not just connected, they're actually hooked. These objects are hooked to the knot. Well, now notice, suppose I pull this object. If I pull this object, well, the knot's going to feel the impact because the object is hooked to it. If I pull this object right here, well, the knot's still going to feel the impact. And I pull this object, well, the knot still feels the impact. Well, let's say I unhook the object from the hook, from the knot. Well, then I just have objects floating in space, kind of. So something like this, right? Well, now notice, if I pull this object, well, there's going to be no impact on the knot because the object was already unhooked from the knot. If I pull this one, same story. I pull this one, yep, still no impact on the knot itself. So what am I saying here? What I'm saying is that the only way this knot is going to feel the impact when we move any of these objects is if the objects are hooked to this knot, right? And let's see, this might seem a bit bizarre, but let's see how it connects to mathematics exactly. Let me take you back to high school, right? So, remember this triangle your teacher might have drawn you? Triangle right there. We call it a right angle triangle. This side is A, this side is B, and this side is C. And I'm sure you very likely remember that you were told that A squared plus B squared equals to C squared. The Pythagorean theorem, right? Let's suppose you actually want to learn this theorem and you want to be able to apply it and use it, right? So this is you back in elementary school at this point. Well, there are many ways to do it. One way you could learn this principle is you could just write it down like I did, and then maybe repeat it yourself every day, or turn it into a song, you know? Maybe something like A squared plus B squared equals to C squared. Well, there's nothing wrong with that, but it's just not efficient, and it doesn't align with what we know about how ideas work. Because ideas have consequences, and ideas are connected to other ideas. It's much easier to remember and use an idea if you deliberately try to connect it with other ideas. But anyways, before I end up rambling here, because I tend to be too theoretical sometimes, let's get specific. So, well, let's think about the consequences of this. You're trying to learn this Pythagorean theorem. Let's think about the consequences of this idea. Well, one of the consequences is that it's not just a bunch of symbols, but it's really telling us a relationship of sides of a triangle. That's the first thing. The other thing this theorem is telling us is that it tells us something about the shortest distance between 2 points, because we all know the shortest distance between 2 points is a straight line, right? Well, this straight line is related to this line here and this line here, another right triangle. So if you call this A and you call this B, well, A and B somehow give you an idea of what the length of the shortest distance between these 2 points is going to be. So the Pythagorean theorem then, this theorem is very related to what the shortest distance between 2 points is, right? Now notice, anytime, because I have successfully hooked this principle of the Pythagorean theorem to other ideas that I know, which means that anytime I see a triangle, automatically the principle, this theorem, the Pythagorean theorem, is invoked in my brain, right? Every time I see 2 points, instantly, and I'm trying to think of the shortest distance between them, instantly I'm reminded of the triangle and the Pythagorean theorem. This increases tremendously the likelihood of me applying and remembering this principle, because it's connected to ideas that I know. Well, now suppose that I hadn't done that. Suppose that I just memorized this, as we said, and stopped there. Well, then this idea becomes what I call isolated. And an isolated idea is really problematic, because one, you're not going to remember it because nothing is going to prompt. Maybe you'll need it for a test, but nothing is going to prompt me. So I'll read a statement, I'll look at a triangle, and no prompt is made in my brain to connect it to this theorem. I'll look at the shortest distance between 2 points, and no prompt is made. It's kind of like very reminiscent of this idea here. If you think of this knot right here as the theorem, right, the theorem we've been talking about, the Pythagorean theorem, well, then if I don't connect it, if it's unhooked, if the theorem is unhooked from all the other ideas I know, then it doesn't matter. Even if whatever happens here, like it really, all the other ideas that I know are not going to trigger this principle, this theorem that I'm trying to learn. And so makes it really hard for me to learn the concept, or at least to retain it, right? And this principle is very powerful, in fact. And let's try another example just to make it super clear. Let's say, back to elementary school again, 2 plus 2 equals to 4. You just went to the class and you just learned this idea, that 2 plus 2 equals to 4. You can try to sing a song about it. You can try to memorize it and repeat it yourself every day. But once again, that would be inefficient, because a better way would be to connect this idea to things you know. Maybe you remember that, well, maybe you have 2 parents, and you have your 2 siblings in the house. Well, suddenly, 2 plus 2, this 2 plus 2 equals to 4 reminds you of the number of family members. Number of family members in your house, right? And maybe you remember something else. Well, your mom gave you 2 bananas for lunch at school, and you picked 2 oranges. You picked 2 oranges from the tree. Well, suddenly the number 4, 2 plus 2 equals to 4, reminds you of number of fruits that you have. Well, now what's going to happen here? Well, every time you look at your family, this idea of 2 plus 2 equals to 4 is invoked. Every time you think of a banana, the idea is invoked. Every time you think of oranges, the principle is invoked, right? These are the benefits of never isolating a concept that you're learning. Every idea is as good as what it can do for you, right? What's the point of learning an idea if you can't use it in any way, and if it can't somehow change your point of view about the world, right? It has to connect and change something, or at least help you see the world in a different way, right? And to formalize everything I've been saying is, anytime you learn an idea, every time you learn an idea, do not think about this idea in isolation. Think about, hook it. Hook the idea to some other principle, some other idea. Let's say idea 1. Hook it to some other idea, say idea 2. Right? Hook it again maybe to another idea, idea 3. And suddenly all of these ideas will act as triggers for the idea that you've started to learn. And therefore the likelihood of you remembering it is going to increase. Well, I've had a lot of fun with this video. This is actually the end of it. If you did enjoy it, please subscribe below, right? And so that anytime I come up with a new video, you'll know about it, right? And very likely I might have said something inaccurate in this video, or maybe I didn't explain correctly, or you have a better idea of how to explain this principle, or maybe you have some other deeper ideas that I didn't kind of touch on in the video. If any of those events happens, please let me know in the comments below, and try to be as harsh as possible, right? So that way we could make sure that together this video and subsequent videos are the best they can possibly be, so that anybody in the world who wants to learn how to learn mathematics we'll learn it here in the best form possible. Thank you very much, and I hope to see you on the next video.